My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase it immediately. You're going to need it. The book contains 230 problem solving questions. It has 174 data sufficiency questions. We have solved every single one of those problems already. If you're interested in watching the original solutions to the problems, you will find the original solutions from day 1 through 250. Right now we are in the process of redoing the problems at a little bit of a faster pace. Let's turn to page number 277. We're going to do problem number 25. The very first problem that you see there on the page. Number 25 tells us that we have invested $5,000 at X percent. We are told that we have invested $5,000 at X percent. We are also told that we have invested D dollars, a different amount, at Y percent. We are not told the percentages, X and Y, we are not told what those are. The question simply is, how much is D? How much is D dollars? This thing seems pretty light to me. I'm going to change this. Perhaps a different would be a little bit darker. Let's see what they tell us, okay? In the first statement, they tell us that the total return is $900. Well, is that enough? Simply knowing what the total return is that enough to figure out how much was invested at Y percent? The answer, of course, is not. This is not enough information. It's not a worthless information, but it's not enough. The first statement is not enough. A, D, B, C, E. A, D, B, C, E. Since the first statement we just established is not enough, the answer cannot be A or D. Again, if you do not know what we just did here, A, D, B, C, E, it's important that you watch the intro. Just type in GMAT, data sufficiency, and intro. Watch that video, make sure you understand how to set up these problems. Let's look at second statement. In the second statement, they tell us that we have invested $5,000 at 6%. Well, we know 1% of $5,000. We know 1% of $5,000 is going to be just 5,000 with the two zeros going, $50. Therefore, 6% is going to be 6 times the amount. 6% is going to be 300. But simply knowing that the return on $5,000 is $300, again does not enable us to answer the question, how much was invested, what's the value of D. Second statement by itself also does not do anything. The answer cannot be B. When we put the two statements together, all we can figure out here is that all we know at this point is that since we earned $300 a year, and since we know the total return is $900, we know now that we must have had $600 on D dollars at Y percent. Again, the problem is, without knowing the rate of return on the D dollars, we cannot figure out the amount of money that was invested that was invested in the second scenario, the D dollars. For example, if we know that Y equals 10, if we can somehow figure out the value of Y, let's just pretend that Y equals 10, then we know that if we earned $600 on an investment that was yielding 10% return, then the money that we invested must have been $6,000. But we do not know the Y, and without knowing the Y, we cannot figure out the D. The answer is E. Even putting two statements together, the answer is E. Even putting the two statements together does not get us anywhere. Let's do the next problem, shall we? Number 26. Number 26. Number 26 tells us that the profit increases though not proportionally with the number of units sold. with the number of units sold. And the question that is being asked is, was the profit more than $4 million on sales of 380 units? Did we make a profit of more than $4 million on the sale of 380 units? Well, we are told that our profit does go up. Our profit does go up with the number of units sold. We are also told that even though the profit does go up with the number of units sold, but it does not go up proportionally. What they mean to say here, when they say though not proportionally, what they meant to say here, what the mathematician would say, and a strict mathematician would say, profit increased though not strictly proportionally. Though not strictly proportionally. Let me show you a scenario here, what it means for profit to go up strictly proportionally. For example, when we sold 1 unit, our profit was $3. When we sell 2 units, our profit is $6. When we sell 4 units, our profit is $12. When we sell 10 units, our profit is $30. When we sell 300 to 100 units, our profit is $300. Here, as you can see, each time we sell 1 unit, our profit goes up by exactly the same amount of money. Our profit goes up in the exact same increments. They have ruled out this scenario. We cannot assume. It says profit does go up, but it does not go up strictly proportionally. But it does go up. They have ruled out this scenario, but what they're telling us is that we are dealing with the situations where we never sell something at cost, whereas at cost, where by the virtue of selling 1 more unit, our profit does not go up at all because we are selling the unit at cost. They have also ruled out the situations that we do not sell anything at a loss. That's not allowed. Because if we sell something at a loss, if we sell the next unit at a loss, then our profit will drop. That is not the case here. Our profit will always go up, even if it goes up by only a penny, but the profit will go up each time we sell each additional unit. That's what that means here. Profit increased with the number of units sold. Let's see what we can do here. But that was a very important concept to understand what we're dealing here. The profit does go up each time we sell a unit. The first statement tells us that the profit is more than 2 million on 200 units. Now the people who are not paying attention, will say, well, if your profit is more than 2 million on 200 units, then you need to go 400 units before it goes above 4 million. You see their logic? You see the flaw in their logic? They are thinking, in order for the profit to be more than 4 million, you need to sell 400 units. Well, that would have been the case if the profits were strictly proportional. We just said, we ruled out, if the profit do not go up by strictly proportionally. We do not know how much the profit goes up. So maybe the profit is more than 4 million by the time we hit 380. Maybe it is less than 4 million by the time we hit 380. We do not know. This does not tell us anything. Simply knowing that the profit is more than 2 million on 200 units does not enable us to answer the question, was the profit more than 4 million by the time we sold 380 units? This is not enough. First statement is not enough. A, D, B, C, E. A, D, B, C, E. Since the first statement we just established is not enough, therefore the answer cannot be A or D. Answer would have to be either B, C, or E. Let's look at second statement. Second statement tells us that the profit is more than 5 million on 350 units. Well, what do you know? If we have already hit a profit of 5 million by the time we sold 350 units, and we are not selling anything at cost or at loss, each time we sell 1 more unit, our profit does go up, then obviously, if we are already making a profit of 5 million on 350 units, then obviously the profit has to be more than 4 million by the time we hit 380. Second statement is enough. Second statement by itself is enough. The answer is B. Second statement by itself does provide us enough information, does provide us enough data to be able to answer the question that is being asked, which is, was our profit more than 4 million by the time we sold 380? The answer is yes, of course our profit has to be more than 4 million by the time we sold 380, because we already hit a profit of 5 million by the time we sold 350. Let's go to the next one, shall we? Number 27. Question number 27. I keep looking here because I left my cup in the other room by mistake, and I'm going through a withdrawal symptom here. I need my tea. Let's go to the next one, number 27. Number 27. In 27, we are told that n is an integer. N is an integer. The question is n even? Is n even? We just have to be able to answer the question, is n even, as long as we are able to say, yes, it is even, or no, it is not even. As long as we are able to give a definitive answer, either in affirmative or negative, then we have done sufficient data. You understand? Let's see what we can do here. Let's see what they tell us in the first statement. In the first statement, they tell us that n squared minus 1 is odd. Well, if n squared minus 1 is odd, that implies that n squared must be even. If n squared minus 1, if one integer before this quantity n squared, one digit before that was odd, then n squared, the next integer, must be even. If n squared is even, then n squared is simply n times n. Obviously n cannot be odd. Odd times odd is odd. But we are told that n squared is even. N squared must be even. Therefore n cannot be odd, n must be even. Even times even is even, n must be even. The question was, is n even? The answer is yes, it is even. Since we are able to give a definitive answer, the point here is not that the answer turned out to be yes. Even if it had turned out to be no, it's not even. As long as we are able to give a definitive answer, then we have sufficient data. Here it's just a fluke, just a chance, just a coincidence that it turns out to be affirmative, but we do have enough information to be able to answer the question. A, D, B, C, E. Because we have enough information to be able to answer the question, first statement is sufficient. The answer cannot be B, C, or E. Answer would have to be either A or D. Now listen, before we go to the next statement, I want to quickly point out that there is actually a more classical, more traditional, more mathematical, more academic way of looking at this situation here, algebraic way if you like, which is to realize that if n squared minus 1 is odd, then n squared we know, n squared minus 1 we know, n squared minus 1 we know is simply n minus 1 times n plus 1. N squared minus 1 is n minus 1 and n plus 1. Of course, the difference of two squares here. And since this is odd, since this quantity we are told is odd, then this quantity has to be odd and this quantity has to be odd, because odd times odd is odd. And if n minus 1 is odd, then that implies that n must be even. So that was another way of looking at it. Or if n plus 1 is odd, then n would have to be even. Let's look at second statement, shall we? In the second statement we are told that 3n plus 4 is even. 3n plus 4 is even. Well, if 3s plus 4 is even, then since this quantity is even, then 3n must be even as well, because even plus even is even. 3 times n cannot be odd, because odd plus even would have been odd. Even plus even is even. 3n has to be even. 3 times n cannot be odd, because otherwise odd plus even would not have been even. That tells us that 3n is even. If 3 times n is even, and since 3 is odd, n would have to be even. Because odd times odd is not even. N would have to be even. Because odd times even is even. N would have to be even, which means that it turns out that second statement by itself is also enough. Second statement by itself is also sufficient for us to be able to answer the question, is n even? The answer is yes, it is even. Notice the answer turned out to be the same. If the answer turned out to be yes, based on the first statement, based on the information that was given to us in the first statement, and if it turns out that your answer turns out to be no, based on the information that is given in the second statement, then something has gone wrong. They never, ever, ever contradict each other. Do you understand? If you find out that based on the information that was given in the first statement, you find out that the Michael is 7-year-old, And then by the time you do the work based on the second statement and you find out that Michael is 5-year-old, something has gone wrong. You made a mistake either in the work in the first statement or your work in the second statement. But that does not work that way. They do never contradict each other. Do you understand? That's all I'm going to do today. I'm not going to start the next two problems because next two problems are a little bit more involved. Perhaps we'll do them next time, tomorrow. Not perhaps, obviously, we're going to do them next time, tomorrow. I'll see you then, okay? I'm feeling a little lazy. I'll see you tomorrow, okay? Bye now.